At the end of the last video I did on using vertical asymptotes to sketch rational functions, I teased this graph and asked the question, how would we even produce such a graph? And that's what we're going to do in this video, and we're going to use our understanding of vertical asymptotes to sketch that rational function. If we take a look at the equation of the function that will produce this graph, which is 1 over x squared minus 4, we can analyze this function in terms of its vertical asymptotes, its horizontal asymptote, and its x and y intercepts. And I'm going to do that using the same process I did in the previous video, where I looked at 1 over 2x minus 1. The first thing I'm going to do is analyze the vertical asymptotes. I know that there can be two vertical asymptotes for this function because there's an x squared term in the denominator. So I'm going to use the same process. I'm going to set the denominator equal to 0, and I'm going to solve for the x values that would make the denominator equal to 0. Because remember, the definition of a vertical asymptote is a restriction on x, and in this case, that's going to happen when my denominator is equal to 0. So setting my denominator equal to 0, I've got x squared minus 4 equals 0. I can factor this expression using the difference of squares factoring method, and I can set each set of brackets equal to 0 and solve for x. So as it turns out, I do have two vertical asymptotes, one at x equals negative 2 and one at x equals 2. The next thing I'm going to ask myself is what happens as x gets really, really big? I'm looking for the horizontal asymptote here. As x gets very, very big, the bottom will get very, very large. Imagine me subbing in a very large number here, squaring and subtracting 4. This is getting very, very big, but the top is staying the same as 1. And we know that 1 divided by a very, very big number is going to approach 0. So we can conclude that the horizontal asymptote will be at y equals 0. To determine the x-intercept, or x-intercepts, I'm going to set the function equal to 0. So I'm going to replace f of x with 0. When I do that, you're going to see that I end up with 0 equals my function. I've got to multiply the denominator up to the other side in order to get x on top. But when I do that, I actually end up destroying my x term, and I have a statement 0 equals 1. We know that's nonsense, so we can conclude that there are no x-intercepts for this function. Last thing I'm going to do is I'm going to set x equal to 0 to determine my y-intercept. So when I sub in 0 for my function, I've got 1 over 0 squared minus 4. I can simplify that and call that negative 1 over 4, or negative 0.25. So just like I did with the other function, 1 over 2x minus 1 in the other video, I'm going to take all of this information, I'm going to use it to sketch a graph. Because I want to keep this video brief, I'm just going to cheat and use Desmos. What I've done is quickly typed in 1 over x squared minus 4, and this is the graph that comes out. But because I'm trying to explain how you would graph this by hand, what I'm going to do is just show you all of the key features on this graph. So you'll recall that I had vertical asymptotes at negative 2 and 2, and you can see here, if I start subbing in x values that approach negative 2, my y values explode very, very quickly in the positive direction. So you can see as my x values get closer and closer to negative 2, my function is exploding. The reason for that is that I have a vertical asymptote at x equals negative 2. Now the same thing's going to happen as I approach negative 2 from the right side, except my function is exploding towards infinity in the negative direction. Again, that's one of the properties of vertical asymptotes. As you approach them, your function explodes towards either positive or negative infinity. We have the same case for x equals 2. I've got a vertical asymptote there. You can see my function's exploding towards positive and negative infinity. If you take a look at the x-axis, you can see that I've got my horizontal asymptote there. As my x values get bigger and bigger and bigger, you can see the y value is getting closer and closer to 0. It won't actually ever reach 0. That's the same if I go into the negatives. Recall that I had no x-intercepts. That's directly connected to the fact that I have a horizontal asymptote at the x-axis. I can't cross the x-axis. I have no x-intercepts. And the last piece of information is my y-intercept, which Desmos kindly displays nicely for me right here. So with all of those pieces of information sketched on the graph, we can determine where the rest of the function lies by simply subbing in points. So for instance, if I sub in negative 3, I would get 0.2. I can plot that point. I can do that for any number of points that I need to confidently produce an image of what this function would look like when sketched. So I've linked the first video I did on using vertical asymptotes to sketch rational functions here. I'm hoping both of these videos help in your studies of rational functions. Feel free to check out the videos I've done on horizontal and oblique asymptotes. As usual, thanks for watching.